The next problem we're going to take a look at involves what are called triangular numbers. The Pythagoreans, which were a band of mathematicians in ancient Greece who worked under Pythagoras, this was a group that was intrigued with a very specific series of numbers: 1, 3, 6, 10, 15, 21, and so forth. Now, the question here that we're going to ask is, what would be the next number in this series? Well, in order to figure that out, you'd have to recognize what the pattern is for this series of numbers. And what we find here is that the nth term is obtained by taking the value n and adding it to the previous term. So if we take a look at a couple of examples here, if we want to get 6, which is the third term, we take 3 and add the previous term to it, which was 3, so 3 plus 3 is 6. Another example is the way we get 10 is, well, that's the fourth number in the series. So we take 4 and we add the previous item in the series, which was 6, so 6 plus 4 is in fact 10. The numbers in this series are what we call triangular numbers. And this is because we can actually visualize these numbers as a triangular arrangement of objects. So let me show you some examples. So we start with 1, which is just a single dot here. But if we go to 3, we see that we can visualize this as a right triangle of dots. Then we have 6, which we can visualize here as another triangle of dots. And then we have 10, and then 15, and then 21. So notice with all of these numbers, we can set it up as a triangular arrangement of dots, or some way of visualizing it as some triangular arrangement of objects. So how would we go about finding some arbitrary nth term? So let's say we want to do that. If I have some value n, what's the triangular number in that particular sequence or series? Well, if we looked at our diagrams, we could just take the columns of the entire arrangement and just add up all those columns. So for example, if we wanted to get the fourth term, what we find is we had one column of 4 things, a column of 3 things, a column of 2 things, and a column of 1 thing. So 4 plus 3 plus 2 plus 1 does in fact give us 10. So we could do this using some type of loop. In fact, here's some code that would actually do that using a loop. So we have a while loop as long as n is greater than 0. We would have some total and we would add n to it and just decrease n each time until n becomes 0. And that total would in fact give us the actual result. So we can go through the loop n times, add n, and then we would do n minus 1 and then n minus 2 all the way down to 1, and we would just stop whenever n becomes 0. We can use a recursive approach instead. So let's think of this nth term as a sum of only 2 things instead of a sum of n things. So here the way we would do this is we would first get the first column of size n, so that would be our first number, and then just the sum of the remaining columns. So for example, if we go back to our earlier example where we wanted to get the fourth term, what we would do is we would take 4, which was the size of our first column, and if we took the sum of the remaining columns, which was 6, add those together, and that would give us 10. If we want to do this, then all we need to accomplish this is a method for getting the sum of those remaining columns. So the question is, how do we get the sum of the remaining columns? Well, keep in mind that what we can do is we're just basically getting the sum of the contents of columns for n minus 1. So remember, if we looked at or picture our example of the fourth term, where we had a column of 4, a column of 3, a column of 2, a column of 1, we can break that up into 2 parts. We have that first column, and then we'd have the rest of it. In fact, let me just try to draw a diagram here. I'll just do a little circles, so we'll do something like this. 2, 3. Okay, so this is close enough. So the way we can think of this is to do our sum, we would get the first column, which is this column right here. And then we would get the sum of the remaining columns. So that's this part right here. But what is this second part? Well, that second part is the sum of the columns for n minus 1. This is the previous term. So we can just write up a method that's based on that, where we would just say get the sum of that particular value. So now all we need is some type of base case in order to solve this. And here we would just say the base case would be where n is 1, because when n is 1, then our value is 1. So now we have a code for a recursive solution to this problem. So we have our base case right here where if n is in fact 1, we're going to return 1 because that's our base case. And then our recursive step is, well, we have this n, which is our first column, and then this triangle n minus 1, that gives us the number or the sum from the previous term. So we just compute that, and sure enough, this would give us the proper number in our sequence.